All right, so I want to get directional derivatives.
Love it.
Okay. So
You don't love it, you dove it.
why would I want this? What would this mean? What would it mean to take a directional derivative? What kind of derivatives do I have already?
Partial and gradient.
Partials and gradients, right?
With
Specifically,
respect to x with respect to
so far, x and y derivatives, right? So, to remind, although I'm sure you guys don't need it since we've learned this like 3 times today,
Ooh, that's a fun spider.
is, let's see, so if I take a x slice, right? That's setting the x value constant, right? I get some function of a and y, right? That thing right here, there's going to be some little slope. That's going to be my fy, right? And then if I slice the other way, that'll be f of
xb.
x and b. And that'll give me some fx slope, right? But say you don't care, right? Like, you're standing at this point, and I want to know about, like, x is this way, y is that way. I want to know about that way. How in the heck am I going to get that information out of x and y?
Could have like an angle component.
Okay, yeah, we could figure out an angle component. Yeah, that's probably a good idea.
And then in that case, you'd have a length of 2 different legs. And you just use the angle.
Yeah, you guys see that? I really want, like, okay,
X part, Y
got
part.
X part, Y part. I want to go that way, right? So I'm looking to answer some question like, what's the rate of change, right, in direction, I mean, like, this way, right? What the heck do you do, like, that way?
45 vector.
Yeah, really, I'd probably do a vector, right? I'd probably say in the direction of the vector. So xy is going to be a really crummy choice. Let me just say v.
I
Right?
thought you said feet.
V.
V.
V. Okay, so there's my x, y information, but really I want to know about the rate of change in kind of that direction, z.
Whatever it may be.
Okay, so I think probably I better get an angle out of that thing.
45.
Yeah, like on this case I might say it's just 45 degrees, right? But there's not really anything special about 45 degrees, right? I'd like to do this in general.
Aren't they all going to be in the same plane?
Ah, this will be in the tangent plane, right? You guys see that?
Mm-hmm.
So really I could figure out, how would I do that? It's definitely in the tangent plane, right? But I really want to know about,
So you can find the angle between the direction vector and one of the slopes,
okay, yeah, that's a good idea.
and maybe use a unit vector for the slope.
Oh, that's a really good idea, right? I don't give any kind of anything, right? How long this vector v is. I really want to strip the length information off of that, only have the angle information. The way I know to do that is to make this v a unit vector. Okay? So I'm going to take that v thing, and I'm going to change it into v over length v. I'm going to call that u. Okay, and then use a unit long. How much did you go in the x direction, and how much did you go in the y direction?
Sine, cosine theta, sine theta.
Yeah, sine and cosine theta, right? How do you get that information off?
Dot product?
A dot product. Yeah, so Let me see. I really want to do this, right? I want to say, okay, it's whatever fx is at a and b, right? Multiplied by what?
Hey, thank you.
While the cloud lasts.
How long's u in the x direction?
Cosine theta.
F, X.
Or yeah, magnitude
Cosine
of
theta.
u. Right?
Yeah, okay, we could definitely do that, right? Or I could just say, hey, it's whatever the first component is, right?
Right.
So I'm just going to say fx at ab times u1, where u1 is the, right, first component of u, and I'm going to let u2 be the second component.
So that's dot product.
So that's scalar
Scalar
multiplication.
multiple. Yeah.
And then, what else is there?
Fy. F sub y would be u2.
So there's fy at ab times u2, right? And I might even remember that this really is approximately the change in f, right? You guys see that? This is really that differential thing I was doing before. Okay. What's this thing? How would you get that?
That's the dot product.
Ooh. The gradient of f dot producted with
With
the
you.
unit vector.
yeah, with a unit vector u. You guys see that? And what the heck would I call this thing? Well, I'm gonna call this
Two.
du,
But
or
you.
maybe df in the u direction. Diffoo.
Bud food.
And really, the notation here is not particularly important. This thing really is the directional derivative in the u direction. That's maybe the most important thing. So let me write that out.
Where's the angle coming
Yeah.
You don't need an angle because that.
Well, we don't
Well-
know. We don't know what the u vector is still. Only that it's in some direction.
Okay, so where's the angle information, right? Anybody see the angle information?
Vector u?
Okay, so one, that's going to be at least partially contained in my unit vector, right? My unit vector is going to give me an angle. But the angle information is also in this dot product, right? That's really where the angle's coming into play in my calculation. I'm going to use it to get the components of u, and then I'm going to multiply by this gradient vector. You guys see this?
So that vector v is just a vector we're picking out of the blue.
That's the direction I'm interested in. Cool. So, should we do an example to firm this up?
Yes.
Okay.